Today we'll be doing the integral from 0 to 1 of x times the arcsine of x dx, and we'll make a substitution. So we'll let L equal to the arcsine of x, which just means that the sine of L is equal to x, which also means that dx is cosine L dl, and that the bounds L sub 1 is the arcsine of 0, which is 0. L sub 2 is arcsine of 1, but that's pi over 2. So L ranges from the closed interval from 0 to pi over 2. And this interval will turn the integral from 0 to pi over 2 of x, which is the sine of L. Arcsine of x, we said it's L, and dx is cosine L dl. And recall the identity that the sine of L times the cosine of L is the sine of 2L over 2. So this is just the integral from 0 to pi over 2 of L times the sine of 2L over 2 dl. This is equal to 1/2 the integral from 0 to pi over 2 of L times the sine of 2L dl. And we'll make another substitution. So I'll let psi equal to 2L, which means that L equals psi over 2, which means that dl is 1/2 d psi, and that the bounds psi sub 1 will be 0 and psi sub 2 will be pi. So psi is from the closed interval from 0 to pi. So this is going to equal to 1/2 the integral from 0 to pi of L, but we said that's psi over 2, and sine of 2L is psi, and dl is 1/2 d psi. And we'll group together the 3 1/2s. So we have a 1/8 the integral from 0 to pi of psi sine psi d psi. So we just got done showing that the integral from 0 to 1 of x times the arcsine of x dx is equal to 1/8 the integral from 0 to pi of psi sine psi d psi. And to solve this integral, we'll use integration by parts. So we can let u equal to psi, so that du equals d psi. We can let dv equal to the sine of psi, which means that v equals the integral of sine of psi d psi, which is negative cosine psi. So this is equal to 1/8 brackets uv, so negative psi cosine psi from 0 to pi minus the integral from 0 to pi of v, and du is d psi. So this is equal to 1/8. Applying the bounds, we have negative pi cosine of pi, and a plus 0 times the cosine of 0, and plus the integral from 0 to pi of cosine psi d psi. 0 times anything is 0. Cosine of pi is negative 1, but two negatives make a positive, so we have 1/8 times pi plus the integral from 0 to pi of cosine psi d psi. So this is just equal to pi over 8 plus 1/8 the integral from 0 to pi of cosine psi d psi, and all that's left is to evaluate this integral. So this is equal to pi over 8 plus 1 over 8 times the sine of psi evaluated at 0 and pi, which is equal to pi over 8 plus 1/8 the sine of pi minus the sine of 0. But notice that the sine of pi is 0, and the sine of 0 is 0. So this whole thing collapses to 0. And we're just left with pi over 8. So now we could say, therefore, the integral from 0 to 1 of x times the arc sine of x dx is equal to pi over 8. And that is the final result. Thank you very much for watching.